Hello, everyone. Thank you for joining us today. My name is Tim Hartman. I'm the Chief Executive Officer of Government Executive Media Group. It's my pleasure to welcome you to today's event, where we're going to be talking about the theme of accelerating AI and analytics from edge to cloud, hosted by Intel. So government agencies and organizations are looking to artificial intelligence and data analytics as a means to better protect and serve their citizens. But deploying the infrastructure needed to support AI at scale remains a challenge for many, given the complexity of achieving high performance and accuracy, all while maintaining costs and utilization. The use of AI in government must take into account privacy and security, compatibility with legacy systems, and evolving workloads. So today we're discussing how to move, store, and process the data from edge to cloud, the data that fuels insights and action. So today I have a few panelists that are going to join me. Daniel Thomas is our Director of Research at Government Business Council for Government Executive Media Group. Gretchen Stewart is the Public Sector Data Science and Technical Director at Intel. And Dr. Irwin Gyanchandani is the Deputy Assistant Director for Computer and Information Science and Engineering at the National Science Foundation. But before we get started with the program, I'd like to go over a few housekeeping items. First, to the right of your screen, you'll find several icons, including the Q&A tab. That'll allow you to ask a question, and feel free to submit those throughout the program, and we'll get to them as we go. And then to start things off, I'd like to turn to you, our audience, for a quick poll. So today we're talking about getting real-time insights, and we want to have a better understanding of where everyone stands currently. So how would you define edge computing? The answers are there. You just click on an answer and you'll log your poll response. A is any point of compute outside of the data center. B is devices, gateways, and computing infrastructure as close as possible to the source of the data. C is a location between the core and endpoints. And D is none of the above or other. And while you're answering that, I will continue to talk through today's schedule. So, we really want to welcome you to discuss some of the applications that are evolving in government. And I think Gretchen's going to talk through some of these. We also have a survey that we've conducted of government managers and some trends and insights that our Director of Research, Daniel Thomas, is going to share with everybody as well. All right, so looking at the answers to the poll, most of you said devices, gateways, and computing infrastructure as close as possible to the source of data. And then many of you said any point outside the data center or a location between the core and endpoints. So this is going to be good fodder for our discussion today. So moving on to our research segment, Government Business Council recently conducted a poll on a similar topic, and later you'll be hearing more about those findings from Daniel. But first, I'd like to turn things over to Gretchen Stewart, who's the Public Sector Data Science and Technical Director for Intel. She'll give us a quick overview of today's topic. Gretchen, you want to take it away?
Yes, absolutely. So hello, everyone. Hope you all can hear me today. I'm delighted to be part of this. Good afternoon, and we're going to have some really great conversations. I put a couple slides together. The first one that you all saw was just highlighting the fact that there's lots of visible and invisible ways that we're seeing AI affect us every single day. And at Intel, we really understand there's a need to provide, I'll call it a fit for purpose, hardware, networking, software, memory, all with optimized storage to ensure that you're on that journey with your data, whether it be from the edge through some gateway all the way back to the data center or the cloud, that we want to make sure that we've optimized those, I'll call them fit for purpose products to ensure that we're taking advantage of all the application, all the analytics that we can, the data that you can analyze at the edge, ensuring that there's probably some of that data that you want to keep back in the data center for some future predictive analytics or some other options that you might be able to maybe not even think of at the time, but data that you might want to use as you move forward in your business. But Artificial intelligence is really interdisciplinary. We were talking about this as just before we started that, for a lot of people, they may not realize, but that the first conference around artificial intelligence and machine learning was in 1956 at Dartmouth College. So it's not as if AI all of a sudden poof popped up in the world today and that people are looking at it. It really is very interdisciplinary. There are new advancements that are happening all the time, but it really is a combination of looking at things that you may know from math class in terms of linear regression or logarithmic regression or clustering or thinking about a number of those kind of Monte Carlo simulation or other sorts of things that you may have learned as you've gone through or in your day-to-day job. But for us and for all of you, it's really about the data. So it's really about capturing that. It's really about ensuring that you've mapped it and classified and have it categorized in a way that you're able to leverage it. So you can use standard data techniques, statistical query analysis, things like that may just be, I'll call them kind of normal or predictive analytics, or if you think about something like Amazon, they use a recommender system. Every time you buy something, they recommend that you might be interested in buying something else. Again, that's the math behind leveraging all the data that you have today and looking at data in the future. There are things around natural language processing. I know that there are a number of folks within the government that are starting to look at that. A lot of chatbots. You call into Small Business Administration or call into HHS or somewhere else, and you are walked through the menu, which is really based on NLP. And there are some really interesting things that we've done with some folks. I'll use the FDA as an example, where they're really looking at getting higher yields and ensuring they're improving the efficiency for crops as an example. So they're leveraging weather data, other data that they're collecting along the way and trying to improve the efficiency, or in some cases even potentially changing when they might plant the plants. Or put the crops in due to some of the climate changes and things like that. So again, lots of things that you need to think about. But the other piece of this, if you think about the math itself, what's really important is domain knowledge. So I think a lot of people assume that, hey, if I just hire a bunch of data scientists, I'll be able to do AI. And the truth is, you really need to have, I'll call them citizen data scientists, or you need to have people who really understand what the data is, what the problems are, and how you might be able to leverage that and interpret it and ensure that you're able to explain what that AI is, that the analytics that you've done in terms of really having, as we call it, explainable AI. One of the things that I just wanted to quickly touch on, which I think is really important, and I appreciate the fact that the government really does understand that it's not only an chief information officer, or it's the IT team that's looking at what they need to do, or it's a data scientist, but that you really do have to have a data strategy. And that it was enacted to law in 2018 that every one of the agencies within the government has to have a chief data officer. So that's one of those things that I think is really important, because in the end, it is all about the data, but it is ensuring that you understand where that data is, how you would want to map it, what are the issues or improved citizen services that you're wanting to provide, or additional research, as an example, that a lot of the federally funded R&D, FFRDCs as they're called, do, and then just a number of other options that are done, thinking about smart cities. And again, when you start to add up all the devices that are out there, and literally they're saying in the next probably 18 months that we're going to have something, in excess of 30 or 40 billion numbers of devices. So think about that. That's more people than are on the planet. So everybody's got 2 or 3 devices that are all collecting data. And how do you want to leverage that data? And just as a kind of, I'll call it a last piece to think about, is how does this connect to the federal government? And there are a number of options in terms of how folks are looking at that, from health and life science to, oops, sorry about that. Had a little bit of a freak out from my system. So here's just some use cases. Sorry about that. It's always fun to go live. So think about the multiple communication networks and the fact that you're keeping track of adversarial warfare, of people broken in, whether you're in the space, the air, the sea, the land domain. Think about signal processing. Think about the unmanned systems as an example, or unstaffed drones, as I like to call them, thinking to be gender neutral. But think about the fact that, as I said initially, Intel's really thinking about fit for purpose. So that means that, you know, a CPU might not always be the right answer. There are things like field programmable gate arrays that are low power and low battery, small space, system on chip. So there's a number of different designs that you might need to do to fit with all the different use cases for the government. And more than anything, it is about the software to ensure that we are leveraging all that the hardware is capable of doing to provide you the best solutions and the best answers. And one of the things that I'll sort of end with, which most people probably don't realize because you think of Intel as a hardware company, is that we have over 15,000 software engineers. And for some cases, that's more than some of the, I'll call them top 10 software companies. And it really is because we are trying to ensure that all the software, whether it be COTS or specifically that you're designing, that we provide the tools and that we've optimized all of that to ensure that you are able to take advantage of all the data and have the best analytics and be able to not only enhance what you have, but potentially leverage other products that are already done so you don't have to start from scratch, so to speak. And with that is kind of a thought process of what we're thinking about and the conversation that we'd like to have, whether it be a research discussion or whether it be other government agencies that we're all working with and talking to. I will then turn this over to Daniel so that he can give us an update on some of the research, which is really interesting, and all of it will be perfect for the conversation we're going to have.
Thanks, Gretchen. Great presentation, very informative about all the different domains that AI touches. And Daniel Thomas is our Director of Research for Government Business Council, and he's going to unveil some of the findings of our most recent playbook on this topic. Daniel?
Thank you, Tim, and thank you, Gretchen. Let me share my screen, and we'll get right to it. So my name is Daniel Thomas. As Tim said, I lead Government Business Council, which is the research division for Government Executive Media Group. Just some context, we're really excited to share some survey data with you today. In July and August of this year, Government Business Council fielded a survey to a random sample of federal government decision makers. The purpose behind this study was to really understand just how federal agencies are pursuing their edge computing needs, also what their confidence is in their own data collection and sharing, and what impediments stand in the way to getting the most out of their data environment. A lot of this does have to do with artificial intelligence, and I think it really provides a good setup for today's discussion. When we fielded this survey, we heard back from close to 160 federal civilian decision makers, and so we're really excited to share some of the top line findings from that data with you today. So before we actually look at the survey data, though, it's worth just kind of pausing and asking, what is this concept, edge computing? It is a more recent term that is used to describe placing Internet of Things or IoT devices, gateways, and analytics as close as possible to the source of data and to the systems and people who need to make data-driven decisions. The edge computing has multiple applications. A few of them are listed there on the screen. And we provided this definition for our survey respondents so that they were aware what it is. And we also provided a few examples. Some examples are hospital devices that monitor patients and that can notify medical crew when vital signs change. Other edge technology includes like digital cockpit systems in commercial vehicles that support driver awareness. And then there are other devices that monitor weather conditions and traffic patterns and that give real-time updates to inform citizens on their transit decisions. You can see here on the right some pretty staggering statistics. 46.1 billion zettabytes of data is expected to be generated at offsite locations by 2025 due to the rise in all of these connected edge technology devices. And then 75% of enterprise generated data will be created and processed outside a traditional centralized data center or cloud by 2025. That is a forecast by Gartner Research, and the previous stat is from International Data Corporation. So let's look at the survey data. So our first takeaway is that there is a huge demand for edge technology. We asked respondents how important it was for them to capture and share information from devices or data sources that are used in the field or at remote locations. And the takeaway here is that 69% of them said it is very or extremely important to be able to capture and share that data in remote locations. Another 19% said moderately important. And on the right here, you can see that when it comes to investments and funding for edge technology, 55% say they believe investments in edge can benefit their agency when it comes to generating actionable insights faster and more accurately. Now, what is the urgency around this topic? So one thing is that there's a majority who believe that edge technology is going to be ubiquitous within just 4 years. If you look at this this graph here on the left, you can see that there's actually a majority here, 51%, who say that they believe that their agency will reach a point when edge technology is being used to generate and collect more data at offsite locations than on-site locations, which is traditionally the primary data center. 14% actually believe that this is already happening. And then if you look at the right, you know, why is this happening? We wanted to ask respondents, you know, what are the incentives, what are the benefits that your organization sees in moving to the edge? And very popular, some of the choices, they were allowed to select multiple options here: boosting collaborative capability, improving service experience for end users, really increasing situational awareness, and also a reflection on that the workforce is just becoming more mobile. Everyone right now is in a remote, nearly everybody is in a remote situation. And with that just becomes, there's a lot more opportunity to leverage that mobility through the introduction of edge technology. Moving to the next slide. Now, that being said, there are still some concerns around how edge technology can be deployed securely. So we asked respondents to give us their confidence level around current security of edge, and the opinion here is definitely more mixed. You can see here on the left that 37% are very or extremely confident in the security, but then there's 34% who are just moderately confident and 29% who are not at all or just slightly confident. That's nearly 1 in 3 who are skeptical about the security of edge technology at this moment. And again, on the right here, you can see that among the options respondents were allowed to select, and they were allowed to select multiple options, cybersecurity concerns at 46% really pops out there. It's neck and neck with other top concerns such as limited funding and expected latent bandwidth issues. Just a few other insights before we conclude this, the research section here. We wanted to know what are the top edge technology use cases that agencies are using right now. Inventory management was the #1, and we're talking about things like RFID tags and that kind of technology. Multi-sensor data collection and fusion, and then computer vision were also high up on the list. 31% say they saw expanded edge computing power as an opportunity to really lower operational costs over the long term. And that being said, there is this continued trend to the remote work and workforce mobility. But the caveat there is that respondents want to federal employees want to make sure that that is secure and safe to use in the remote environment. One respondent, we've actually included a quote here from them. They said in verbatim, "It would be nice to have interaction that meets or exceeds the security necessary for government employees, especially now when we are teleworking more." So I think this provides a good backdrop for today's discussion around artificial intelligence and where things like edge technology can play into that. And before I'll turn it back over to you, Tim, but I invite our attendees today to be on the lookout. Government Business Council, the research team, will be publishing a report in partnership with Intel on this very survey data and the actionable insights we got from it. Thank you.
Thank you, Daniel. That was great. That was a great way to set the table for today's discussion. And so now I'll bring our panelists back. We have Gretchen Stewart and Erwin Gyanchandani. First, let's turn to Erwin. Can you briefly describe, as you come into the event here, tell us what you do and your responsibilities at National Science Foundation?
Sure, absolutely. So, Tim, first of all, thanks for having me on this panel, and thanks for having me be a part of this session. Certainly a very timely and I think very important topic for all of us to really be thinking through. So my role at the National Science Foundation, as you mentioned, Tim, I'm the Deputy for the Computer and Information Science and Engineering Directorate. You might hear me slip and say CISE. When I say that, I refer to the acronym of our directorate, CISE. Maybe before I even talk about what I do, I'll talk a little bit about what NSF does. So the National Science Foundation has been around since 1950, chartered by Congress. And our mission really is to be able to support foundational research and education in all areas of science and engineering. So we support advances in everywhere from astronomy to biology to chemistry to geoscience, understanding about the Earth, to physics and beyond. And we do so by primarily supporting academic institutions, researchers and students on college and university campuses throughout the US to be able to identify research problems, pursue them, yield discoveries, yield innovations that can impact society and impact our economy in the long run. And so my directorate, Computer and Information Science and Engineering, we have a long track record of doing just that for the computing and information fields. So a lot of what Gretchen and Daniel were talking about, I think, is really very much in our wheelhouse. We invest in fundamental research that can open doors for tomorrow's long-term impacts on our economy. And we do so in areas from the foundations of computing, like new hardware paradigms as we see Moore's Law and where Moore's Law is at the moment, to new computing systems, edge computing, cloud computing, hybrid computing models, to network security and privacy types of issues, to, of course, data and information, machine learning, artificial intelligence, and so forth. And so I'll just say that today's AI revolution that we all are talking about, for example, has its roots in NSF-funded research that goes back over many decades. There was the example that I think Gretchen gave during her presentation about Netflix and systems that are recommending movies to you or recommending products to you, right? That has its roots in technologies, techniques, capabilities that were pioneered going back to the 1990s, a technique called collaborative filtering, for example, that I think is foundational for that capability. So that's really what we're set out to do as an agency, to try to support discoveries and innovations that will have long-term impact on our economy. And I'll just close by saying that I think we're really excited about something that we announced a couple of weeks ago, the National Artificial Intelligence Research Institutes. So every year, NSF invests on the order of about $500 million in artificial intelligence research and education activities. And we are, in effect, doubling down on that investment. So a couple of weeks ago, we announced that we were going to fund 7 institutes, 5 funded by NSF, 2 funded by the U.S. Department of Agriculture's National Institute of Food and Agriculture, as part of a multi-agency partnership to really stand up large, multi-institutional, multidisciplinary centers, virtual centers on campuses, college and university campuses throughout the U.S. to be able to innovate in everything from the foundations of artificial intelligence to more use-inspired areas like AI in agriculture or AI in energy or AI in transportation and so forth. And so we've announced the first set of 7 institutes that we funded, which have a number of partners, and they really are nexus points. So those 7 institutes span organizations that touch nearly half the states in the United States, and including academia as well as industry as well as nonprofits. And we're looking forward to the next set of institutes that we are hoping to fund about a year from now. We put out a call for proposals last week for institutes in 8 different thematic areas. So on the whole, we're really looking to try to innovate in terms of the artificial intelligence techniques and capabilities that can be brought to bear in the government sector, in the private sector, in the longer term for our nation.
Thanks, Erwin. That's a great introduction. I'm wondering if you could go a little bit deeper on even just internal to National Science Foundation. How are you looking at the role of artificial intelligence for NSF and then for government overall, in addition to some of these initiatives that you just announced?
Sure. So in terms of within the foundation, our bread and butter really is processing proposals that come into the agency. So every year we get on the order of between 40 and 50,000 proposals from the research community to be able to, you know, with ideas of how we might be able to make advances in the different areas of science and engineering that we support. And so we, as part of that, we take those 40, 50,000 proposals and we put them through a merit review process. So we bring in external experts who can help inform us in terms of the intellectual merit, the techniques, the novelty of the science that's being pursued, as well as the broader impacts. What's the impact going to be on society, on the economy, on education, workforce, on voting participation, and so forth. And so a lot of time that's spent by our program staff is really to be able to identify subject matter experts who can review these proposals. And so one of the things that we've started to do in the last year or so is to take natural language processing and other learning techniques to really be able to try to match up prospective reviewers with proposals that we have so that we can line up that subject matter expertise in a meaningful way while also ensuring that the reviewers are not conflicted with the proposals, because we want the review process to have as much integrity as possible. And so that's an example of us trying to bring AI to bear in real time. In terms of our day-to-day processing, it ends up saving countless hours of time on the part of our program officers, if done well, in terms of being able to surface potential reviewers. And that time can then allow them, that time saved can allow them to potentially be able to use their time to other means, right? To be able to put their time to identifying gaps and other opportunity areas that we should be investing in that maybe we're not doing at this point. So that's what we're doing within the agency. I would say in terms of beyond NSF to other agencies, I really look at, for example, the AI research institutes as an area where we're really trying to facilitate that. So take our partnership with the USDA, National Institute of Food and Agriculture. We're working with them to be able to bring AI techniques to some of their core mission areas, like, for example, food production and synthesis, and better understanding of how you can grow crops in different areas, and better alignment of data to ability to access water for those crops and so forth. So I think we're really trying to be able to open up those doors through those types of collaborations that we built out.
That's great. And Gretchen, I'll turn to you in a second, but before we do your answer, I want to remind the audience that we are taking questions. You can submit questions to the Q&A module, which should be on your screen, and we want this to be, as interactive as possible. So if you say anything that you want us to follow up on, if you just have a question about something that we've said, please don't hesitate to send it in. So Gretchen, tell us what some of the big opportunities that you see in government for artificial intelligence are today.
Hey, thanks so much for the question. And I want to leap off some of the stuff that Erwin said, and also to just really highlight that the answer is definitely industry working with government, working with research. I think the truth is that much of the exascale work, or you look at AI for science at the Department of Energy, their 200 and some odd paper that they wrote about different techniques and the combination of hardware and software. I mean, Intel and a number of other industries are all part of those kind of conversations, and we're going to solve these hard global government and citizen problems together. And I think, and I applaud the idea of really pulling together these kind of industries. Myself having, I know, probably written some support letters for folks, but it's absolutely critical. We know fully well that it's all of us working on this together are going to, be able to solve some of those problems, the crop yields and improvements on efficiency and those kinds of things. In terms of the, what we do at Intel as an example, we have for quite some time been using analytic techniques in terms of improving our overall yield of processors to ensure that we have the right mix of, sand and other materials that we use to build the silicon. And these are things that we've done for some time. We are working more with robotics in different parts within our factories, but still there's a huge piece of the human to robot translator that's absolutely critical, and those skills are really important. We also just leverage simple, text conversion techniques. We also look, as we're thinking about applying for and putting in for patents, a lot of that leveraging analytics and AI to go quickly through, is there anybody else who's provided something that's at all similar as we're going through our patents? Is a good example. But working with cloud providers, Google and Amazon, and working with DISA and Microsoft Azure to really look at even crowd analytics from a safety and a security perspective. Thinking about, okay, some of that's going to be local, but the truth is they really, in some cases, do need some incredible compute power, and therefore they're leveraging some of that within a cloud vendor. And using social media analytics and others that allow improving services for citizens. Those are some of the ways that I think government can and is starting to, but can do a lot more, leveraging those structured, unstructured, multiple kinds of data to really be able to improve not only federal, but state and local kinds of services for citizens. I think there's a lot of opportunity there. They're starting to do that more with predicting patterns as, and this was kind of pre-COVID, but traffic patterns and things before and after events, where to particularly, in some cases, maybe even have patterns redirected or changing the timing of the lights. All of that kind of stuff are things that are being used and will continue to be used and enhanced and improved and inferred on more and more, I think, as we have those kind of opportunities. But again, as I said first, I think it's the only way we're going to do all of these is a combination of industry and government and researchers and university folks to be able to solve these kind of problems.
Erwin, can you share a few examples of where you're most bullish about the opportunity for artificial intelligence from the research that you've done?
Yeah, so I hesitate to say where I'm most bullish because we're not in the business of picking winners or losers, as you know. But I guess I will say a couple of things about that. Let me first double down on what Gretchen just said about public-private partnerships, right? I think that those are really, really valuable in terms of being able to surface challenge areas and being able to then potentially bring the collective minds together. The collective wisdom can take you much further than individuals working in silos, for example. And so breaking down those silos and bringing academia and industry and government together, I think, is really a potential huge path forward in terms of trying to identify some of these use cases and then tackling these use cases. I think Gretchen hit on a number of areas. I'll just touch on, I'll give you a sampling of the topic areas that we just funded under the AI Institutes program, because I think that maybe addresses this question a little bit, Tim. So, we funded a team at University of Oklahoma in Norman, Oklahoma, to really try to improve the trustworthiness of AI techniques as it relates to being able to, the techniques that underpin weather models and weather predictions, as well as predictions around atmospheric and oceanographic sciences more broadly. Right, so really trying to be able to bring AI techniques to bear on weather and safety, which has huge implications in terms of individual safety, but also huge implications in terms of the economy as well. Another example that I'll highlight is an effort at the University of Colorado Boulder, an AI institute there that's going to focus specifically on the fundamental challenges and applications of machine learning in and collaborative learning in trying to see how people learn through speech, gesture, gaze, facial expressions in classrooms and so forth. So I think that you really have the potential. Those are just two, right? You really have the potential to be able to say that artificial intelligence is starting to transcend a whole host of sectors of our economy. Gretchen mentioned earlier smart cities. So we at NSF have a program called Smart and Connected Communities that really dovetails with this, where we're trying to bring researchers together with residents in cities and communities to be able to surface the challenges that those communities are facing. It could be wastewater management. It could be the watershed more generally. It could be transportation and traffic management, as Gretchen alluded to. It could be energy and electricity delivery. We're seeing the implications of that on the West Coast right now with the wildfires that are taking place in California, right? So in each of these areas, there's the potential to be able to, once you have data, to be able to mine that data and potentially find interesting insights that can be informative to decision makers and that can save dollars, it can save lives, it can potentially have longer term impacts to economy and competitiveness more broadly.
Well, those are very timely examples, right? This is exactly what's going on. And personally, I'd pay a fortune right now to have something that helps my kids be more interested in school on their device. Gretchen,
right.
what are some of
Oh,
go ahead.
I was just going to say, I mean, I think that, that is the power of these sorts of techniques and technologies that we can unlock if we bring the set of stakeholders from academia, industry, universities, and government working together in a meaningful way.
And Gretchen,
Yeah.
can you share a few examples of where artificial intelligence is making a real world difference on operations, citizen services, or strategic decision making?
Yeah, I'm going to jump in and kind of add to the education piece, because that's one of the things that, literally some of the largest cities in the US, sort of picked up the phone and said, I need 5 million laptops for my students, and oh, by the way, just having that many laptops, there's also a connectivity challenge. Yes, 5G and other, additional um, networking capabilities are going to be able to enhance that. But in some cases, literally, some cities have taken school buses because the schools are not running right now, and have taken and tricked out those school buses to be basically small data centers in some of the challenged connectivity places within cities, as an example. And they're starting to look at doing some of those kinds of things remotely, because if you're using, Chromebooks, everything needs to be pulled onto that device. And so it's not as simple as I just open it up and I get to what I need to. It's always needing to be streamed. And they're starting to look at, as an example, are there ways that you can do better predictive analysis on who's taking how much time is a student taking on this particular lesson versus that lesson? Is that particularly a flag where someone needs to jump in? Do we need to create virtual mentors? Do we need to create virtual chat bots that would help students move forward faster, because you cannot have a live teacher at some points, being able to talk to 40 kids at the same time. So there's an example of the kinds of things that, because of the world that we're in right now, it's forcing us to think about things differently. And as Erwin said, it's also with the even larger kind of the cultural challenges and things that we're thinking about, it's really providing a way for us to have a huge amount of diversity thinking about these kinds of projects and problems, and coming up with the answers, I think, better and more interesting and faster. And that's just an example around education. But I think some of the the cities are starting, as an example, to use very small 3D cameras, like an Intel RealSense camera, but a 3D camera within the wastewater to be able to better understand those flows, and are there particular problems, or is there erosion or places within some of the piping systems that needed to be redone. The truth is, I think a lot of that had already started with some of the oil and gas customers, but you can take some of those kinds of techniques and things that have been done in industry and then put those into some of the smart cities. I mean, and again, it's just that combination of people with different backgrounds, different diversity, start to think about, oh, there could be interesting ways to apply these kind of techniques to the data that's had, whether it be structured or unstructured.
And Gretchen, the backbone of a lot of these technologies, as Erwin was talking about, is data, and data storage plays a big role in this. So how should agencies collect, store, and process their data to set their artificial intelligence programs up for success? What do you recommend?
Well, I have to say some of the agencies that I've talked to in some cases, and I don't want this to sound as bad as it might be, they don't even know where their data is. And in some cases, they're not even sure what data they have captured or not captured. In some cases, they probably have collected and just stored a whole bunch of it in simple um, databases and not really understood the potentially the value, or in some cases it's data that they really should just drop on the ground. It's not really ever going to be of interest. So I think some of it is just the initial discussion of where is it? What is it? How do I map it? How do I think about labeling it? And then what really are those hard problems? And am I collecting the right data to help solve some of those hard problems? It's kind of this combination of things. Just storing them in a columnar database is probably better and easier to access than, an older style database. But at the same time, if it's rotten and useless data, then it really doesn't matter how it's stored, if you know what I mean. I know it
Erwin, how do you
sounds worse than it is, but
Erwin, how do you look at the data problem, right? You're talking about advanced AI, but underneath of that has to be an infrastructure of sorts. What are some of your experiences with building that?
Yeah, absolutely. So, we have an office within my director, we have an office of advanced cyber infrastructure that really has a mission of trying to be able to help the research community come together and coalesce around kind of the data infrastructure challenges that we see. So how do you make available data sets in a meaningful way? I'll tell you that for NSF, for a number of years now, we have actually required all proposals to the foundation to include a data management plan. That is to say that we ask our PIs, our researchers, to actually specify in their proposals what is it that they're going to do with the data that they are generating, how are they going to make it available to the rest of the research community and to the public writ large, what are the steps that they're going to take to be able to preserve and save that data. We've also taken steps to encourage different parts of the research community to think about repositories of their own accord, right? So for example, we have for many years now funded the National Ecological Observatory Network, or NEON, which is really an observation system, a platform to be able to sense information in real time about ecology and the environment, to be able to then capture that information. And so the NEON community has made that data available through a NEON data catalog that's available to the broader research community. Similarly, we have an effort together with our colleagues at NIH around the Protein Data Bank to be able to try to make available 3D structures of large biological molecules, which these days, as you can probably imagine, is really important for a variety of reasons. So I think, we really start from a place of trying to encourage the research community from day one as they're conceptualizing a research project, as they're going about collecting and integrating data sets, to be able to make those data available longer term for the community. And we continue to try new approaches for that. I think that being said, I will say that at an agency level, in terms of the federal government, just to kind of build directly on Gretchen's point, there are a whole host of challenges that agencies face when they do know that they have data available as well, right? So there's the problem of not knowing that you're sitting on data. And then there's the problem of you have data, but you have challenges of making that data available because it has all kinds of privacy information in it, right? Personally identifiable information. And so that's another area that um, we at NSF are looking at it from a research standpoint. We find a whole host of research in security and privacy. And so can we bring some of those privacy research results to bear in the federal government to be able to enable our partners at various agencies to make their data sets available in secure enclaves, for example, to abstract away the privacy labels and to be able to present data in a way that preserves privacy for the original source points of that data. I'll give you a very concrete example. Our colleagues at the Department of Transportation Federal Highway Administration, they've done a study over many years where they have, with of course all of the appropriate IRB compliance issues and so forth, they have retrofitted thousands of cars around the country, and the individuals driving those cars know about it and everything, but they're collecting real-time data from highways and videos from highways as drivers are driving along the roadway. Well, there's lots of personally PII that's associated with those data, and so they have to keep that locked down right now in a database on site. And so we are working with them trying to bring some of our privacy research to bear to try to see if we can't make some of those data sets available to the research community anyway, to be able to leverage those data sets and make better sense of new machine learning techniques and also insights, actionable insights associated with those data sets.
That's great. And as we talk about just the proliferation of data, one of the themes today was about edge computing. And one of the big drivers of the edge and drivers of data is edge devices. And I just want to go back to what Daniel shared, that in their survey, 7 of 10 respondents in the government considered the ability to capture or share information from devices at the edge as very or extremely important to their agency's mission, right? So the agency's missions are moving to the edge, right? And as we have our cell phones to respond to the census, for instance, I was able to, fill out a form on my phone. It's proliferating. But how do we set up an infrastructure that can capture the data quickly and turn them into insights? And what are the major differences between leveraging data generated at the edge versus data that's generated in on-site locations? Gretchen, do you want to kick us off there?
Sure. I mean, some of the data at the edge, so depending on what kind of products you have, you can do analytics right there at the edge. So you can, let's say we're talking about visual data, and it's a VPU, a visual programming unit that's right there at the edge. It can do a lot of the license plate good, bad. It can do a lot of that kind of testing. Oh, are all the slots in the parking lot full, or are there still some available on, the third and fourth floor, those kinds of things. And the truth is, once that data is done, in some cases they just kind of drop it there and they don't even keep it. In other cases, they do then take that encrypted and send it back to a data center and leverage that data for, let's say, oh, there's always a particular time from 3 to 5 where it empties out or fills up or whatever. So they can use it as for future data. But it really does, it's really important to know honestly, what the hardware is and what are the components that you're using, and then really ensure that you're building in secure enclaves. I mean, there's some products that not only Intel but that others have built, but Intel specifically has done some things where we are able to literally peg certain amount of core, memory, storage, peripherals to a particular enclave where the data is, and nobody can break into that. And that is done at the hardware level. So there's some of those kind of techniques that people take advantage of. There are things like that that are built into system and chip. They're built into sensors. So those are the kind of at the edge. and then ensure what data you do need absolutely has to be encrypted, and that you understand where that private key is kept, and that private key is kept separate from the data. So there's some of those kinds of things that you need to think about. And those, again, are all really part of someone's overall data strategy. And as Erwin said, kind of the thing that you think about when you're doing any kind of research, or just setting your environment up, that you really need to not only think about that, but also the governance. Are you, talk about transportation, that information would absolutely be helpful for state and local. So what's the governance model? And sometimes I think, even I'll use the fusion centers, which brilliant use of information kind of came out after 9/11. But I think the biggest challenge was around trust and governance. Not even so much about where you store the data or how you store the data. It was as much as who shares what's private, what can we keep, where are the keys for that information, et cetera. So it's a multi-layered, four-dimensional kind of cake that you're building when you're really thinking about all this.
Yeah, Erwin, I imagine that in your proposals, you're getting a fair amount of edge computing and people using sensors and things like that for some of the research projects they're working on. Are you seeing a trend in that?
Oh, absolutely. I mean, I think I'll give you an example of a great project that we've funded not too long ago, the Array of Things project in Chicago, right? Which some folks on the line may be familiar with. So that particular effort is really about deploying sensor nodes on telephone poles or power poles in and around or on the sides of buildings, right? But being able to deploy sensors that allow you, and cameras that allow you to have a better understanding of traffic patterns, understanding of temperature, climate levels, and so forth, pollution levels in the city. I think when our researchers were funded to take on that project and to start deploying some of those nodes at the edge, exactly what Gretchen just said about privacy issues and trust issues. I mean, I think they came to fore front and center. The community in which those sensors were being deployed, right, started to ask questions about how are you going to do this, and what does this mean for me, the citizen walking down the street, when I see this camera? Is it going to take a picture of me? What's the implication of that, right? And so there had to be conversations had between the researchers themselves and the local community to be able to get folks to understand. I think first and foremost is understand, what are we trying to do with these sorts of edge systems? What is their capability? What happens to the data? Where does the data go? I think trustworthiness is really critical in order to be able to make this happen. And that's not strictly a technical issue, right? I mean, I think that a lot of what we're talking about in this conversation this afternoon is and requires a realization that this is about bringing the human world, the social sciences together with the computing sciences in many ways, right? And trying to understand the context in which something is being deployed and the implications of that is just as critical to what is the technology that's on that chip, or technology that's on that sensor that's at the edge.
Yeah, and I think that's great. I mean, I think that one of the things we want to ask the audience about here is just if everyone could get ready for the next poll. We wanted to hear what you thought about this. The question is, my organization is constantly pushing to expand computing power beyond data centers to reach more remote locations. Just agree, neutral, disagree. We'd like to get everybody's sense of that as well. While we're waiting for the answers to that, we got a question from the audience that just, can the panelists address some of the challenges with scaling AI applications in government agencies, especially as it relates to mission critical systems? So, Gretchen, do you want to take a quick first pass at that question?
Sure. So what we've done, honestly, not only ourselves, but in concert with folks, Google and Microsoft, et cetera, is give you a lot of the open source capabilities. So I'll start with, you can go to GitHub and download, Intel optimized PyTorch or whatever it might be that you would want, TensorFlow, et cetera, those frameworks. And then what we have suggested to folks is that, just try out the work that you're doing locally with a small set of data, and then we have an AI developer cloud that folks can go and use and request even larger amounts of CPU to do CPU, FPGA, et cetera, to be able to test out and see how that scales before they then take it to the cloud, or you can do, or you can just jump to the cloud and scale. We found that start out with a smaller model, do kind of a test and dev, I'll almost call it an AI factory, see what works, what's giving you the kind of results, and then take that and scale it across multiple systems. If you're leveraging a lot of the already optimized, honestly, Intel, tools, then by default it will scale. And in some cases, there may be some additional tweaking that you might have to do. But again, the initial application that I mentioned, which was work that we were doing with the FDA, the researcher who was doing that particular work, they were leveraging a number of machine learning techniques, did that locally, and then put it out into a larger environment and saw that it scaled and got over 200% performance improvements based on the work that they had been doing. Again, just leveraging code that was already available and optimized.
Well, I'll just go back to our poll results that we got here. We got a good variety of answers here, but we got a small percentage is looking that they agree that their agency is pushing things out to the edge, and a larger number are saying that they're neutral. I think we're already down the path their way a little bit there, but we're almost at time here. So I wanted to see, from Erwin and Gretchen, maybe just your wrap-up comments on what are just some practical takeaways, as you think about advice that you would give other people as they're going down this journey. There's definitely a hunger for this technology and artificial intelligence and building the infrastructure and edge computing and, sensors and devices. What advice would you give people who are just getting started on this? Gretchen, do you want to kick us off?
Sure. I'll start with I'll call it crawl, walk, run. I think it's important. There are a lot of times conversations that I've had where, the agency wants to leverage all of that data to be able to solve all the problems right away. And I think it really does make sense to think about what the specific issues and problems you are trying to solve, and honestly rationalize them in a priority order, and then take the first one or two and test it out and see what works. And truthfully, once you get one or two of those projects to work, it's much easier to then replicate that in a larger way. So as my dad used to say, don't boil the ocean, so don't try and do it all at once. But again, look at prioritizing some things, and the truth is leveraging others within the government, industry, and research. There's a lot more information than probably most people know. As Erwin mentioned, there's a lot of folks that are allowing their data to be able to be leveraged. Dataverse is one at Harvard that Intel uses a lot because it's got really good social science and gender and race kinds of things, that we're taking a number of those data sets and combining those with work that we're doing with the Broad and others around COVID, and looking at that multifaceted issue.
That's great. And Erwin, what's your parting words here? What advice do you give to everybody?
So, I was thinking about it as Gretchen was talking. First of all, I couldn't agree more with what Gretchen said. I love the crawl, walk, run sort of metaphor there. I guess I'd offer kind of two, maybe three quick reflections. So one is, Tim, I would encourage folks to not think of our data and AI enabled initiatives as just technology solutions. I sort of hit on this in the previous question, but wherever possible, think about it as human technology collaborations, right? I think for this to be successful, we really need to find ways in which we can bring AI together with users and with co-equals in some sense, to be able to move the needle forward in terms of a particular scenario or decision-making characteristic. So that's number one. Not strictly technology, but human-machine collaboration, I think, is really key. The second piece that's very related to that in my mind is education. And that means, workforce reskilling and upskilling, right? We have an incredibly I think, undervalued sometimes federal workforce across the federal government. I should say, and as part of that, I think there's an opportunity to, in many cases, further skill some of our workforce to become more understanding of what AI capabilities actually are, become more understanding of how we can work side by side, some sort of technology or platform to be able to do what we're trying to do. And then the final piece I would say is back to where we sort of started, and Gretchen hit on this a little bit, collaboration, right? This is going to take and this is not where I'm talking about human-machine collaboration, but collaboration in general, trying to bring together folks who have tried this and been successful in another setting, whether it be across government and industry, across government and industry and academia. I think bringing together a variety of perspectives is really critical. And those are some of the principles that we have at NSF that we've been trying to pursue as well.
Well, that's a great place to wrap. I want to thank Gretchen Stewart of Intel and Dr. Erwin Gyanchandani from the National Science Foundation for joining us today. Daniel Thomas, who presented the research earlier today. It's been great. On behalf of Intel, I'd like to thank you, the audience, for tuning in and joining us today. Please be sure to take a minute and complete our short survey at the conclusion of the event. We're curious to hear your feedback, which is going to ask you, as a result of today's webinar, how likely are you to consider Intel technology for your AI projects? So today's program will be available to watch on demand. We've got a couple questions about that. We'll definitely send the link out. Please review it and send it along to other colleagues that might be interested as well. And thanks, everyone, and have a great day.